The morning of August 12th, 1943, a pale sun hung over the Sicilian hillside near Troina as Oberingenieur Hans Kleist stood beside the wreckage of an American column. Smoke drifted lazily from an overturned half-track, its white star still visible through soot and dust. The vehicle's steel body bore the scars of shrapnel, but the machine itself remained strangely intact, an angular utilitarian thing with broad tyres in front and tracked suspension in back. Kleist was not a frontline soldier. He was an engineer from Henschel's automotive division, temporarily attached to the Heereswaffenamt, the German Army Weapons Office, to evaluate captured Allied equipment. Around him, men from the Technische Dienststelle, the Technical Intelligence Detachment, waited in silence as a recovery truck idled nearby. The order was clear: transport the captured American M3 half-track to the German test center in Versailles, where specialists would determine how the enemy had managed to build such vehicles in quantities that seemed to defy all known industrial logic. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. For nearly 4 years, German propaganda had portrayed American equipment as crude, mass-produced, and inefficient. The Reich's engineers, trained in the tradition of exacting craftsmanship, believed that only precision, painstaking, handcrafted, mathematically pure precision could produce reliability. The Americans, they insisted, lacked both the discipline and the tradition of true engineering. And yet, as Allied forces poured ashore in Sicily in quantities the Germans could scarcely imagine, those same crude vehicles were everywhere, hauling artillery, carrying infantry, towing guns, and moving supplies with mechanical nonchalance that defied every assumption. The M3 half-track, the machine now, chained to the back of Kleist's transport truck, symbolized that contradiction. It was neither tank nor truck, but something in between, a hybrid design that appeared almost inelegant by German standards. To an engineer steeped in the doctrines of Deutsche Wertarbeit, German quality workmanship, it looked like an industrial compromise. But as Kleist watched Italian roads choked with these vehicles, still moving despite the dust, heat, and overloading, a suspicion had begun to grow. The Americans, he thought, might have discovered something Germany had not: the mechanical art of sufficiency machines that did enough, built quickly, built by thousands, and built to work. When the captured half-track arrived at the Versuchsstelle Kummersdorf, the sprawling weapons testing complex south of Berlin, it was greeted with curiosity. The facility already housed captured examples of American Shermans, British Churchills, and Soviet 34s. Yet this vehicle was different. It was not a weapon in the traditional sense, but a tool of mobility, the connective tissue of an army in motion. The M3's technical dossier, compiled by U.S. Ordnance, described it simply: carrier, personnel, half-track, M3. But its implications were far from simple. Built by companies like White, Autocar, and Diamond T, the M3 was powered by a 6-cylinder Hercules, or White 160 AX gasoline engine producing 147 horsepower. It could carry a 12-man squad and maintain a road speed of 45 kilometers per hour. Range exceeded 300 kilometers. Production numbers by mid-1943 had surpassed 53,000 units, more than the total number of all German half-tracked vehicles produced since 1939. Kleist's team began by examining the construction. The hull was made of rolled homogeneous steel, but thinner than expected, only about 6 millimeters at its thickest. German engineers immediately noted this as a weakness. Their own SD, KFZ, series like the SD, KFZ, 251 used armor up to 14 millimeters thick. To them, protection was a virtue. Every extra millimeter was insurance. Yet when they studied the American machine's undercarriage, they realized the Americans had designed for an entirely different battlefield philosophy. The M3 was not meant to stop bullets, it was meant to keep moving. Its front axle used conventional pneumatic tires, taken almost unchanged from commercial trucks. Its rear tracks, each supported by a simple suspension of vertical volute springs, were cheap to produce and astonishingly easy to maintain. The Germans were accustomed to complex torsion bar systems or overlapping road wheels, which provided smoother rides but demanded precision machining and constant servicing. Here, by contrast, was a design that any farmer's mechanic could repair with a wrench and a hammer. The powertrain stunned them even more. The engine, a straightforward inline-six, ran on ordinary gasoline, no high-octane blend, no exotic additives. It started instantly even after weeks of disuse, a feat that their Maybach and Horch engines often failed to accomplish in cold or dusty climates. The carburetor, though primitive by German racing engine standards, had been built with wide tolerances, forgiving of dirt, bad fuel, and rough handling. When the engineers measured clearances and compared them to their own production standards, the numbers made them pause. The American tolerances were looser by nearly a third. Yet the machine still ran smoothly. It was, Kleist wrote in his first report, as if the Americans have learned that perfection in design does not mean perfection in performance. They have accepted imprecision as an element of strength. That line circulated quietly among the Kummersdorf staff and reached Berlin within days. To the Heereswaffenamt, already facing acute shortages of skilled machinists and alloy steels, the implications were enormous. If a combat vehicle could function reliably with looser tolerances and simpler materials, it could be built by far less specialized labor. The Americans, they realized, had industrialized not just production, but mechanical forgiveness. The M3's interior told a similar story. The seats were simple, tubular frames with canvas. The dash contained only the essential instruments: speedometer, oil pressure, fuel, and temperature gauges. The controls were arranged intuitively, labeled in English with clear block letters. Kleist compared this with the SD KFZ 251, where gauges were unlabeled, switches scattered, and mechanical systems demanded trained drivers. In the M3, a civilian could learn to operate the vehicle in minutes. But the true revelation came when the Germans studied the manufacturing marks. Every component bore a serial code stamped into the metal engine: differential, gear housing, even individual track shoes. Each was identical, standardized to permit full interchangeability. A broken part could be replaced from any other vehicle without hand fitting. In the Reich, that level of interchangeability was virtually unattainable. Even within the same model line, parts from one 251 often required filing or adjustment to fit another. It was a symptom of Germany's reliance on small batch production and artisanal methods. By September 1943, the captured M3 had been completely disassembled. Drawings filled entire tables, with German engineers mapping every bolt and bearing. They were astonished by the simplicity of the drive system, a 4-speed manual gearbox coupled to a transfer case that drove both the front axle and the tracks. The front wheels provided steering up to a certain radius, beyond which the driver could apply track brakes for sharper turns. There was nothing elegant about it, but it worked under any condition. Mud, snow, or sand, its hybrid drive could adapt. Reports from the Eastern Front added context. German motorized infantry units struggled constantly with their SD, KFZ, vehicles bogging down in the Rasputitsa mud, while American and British columns moved effortlessly across similar terrain in North Africa and Italy. Field intelligence now offered an explanation. The M3's wide tracks distributed weight efficiently, while its front wheels allowed better steering control on roads. The vehicle's unsprung simplicity meant it could survive neglect that would cripple a more refined design. When Kleist's findings reached the Army Ordnance Office, the reaction was immediate and almost desperate. In October 1943, a memo circulated through Berlin's Ministry of Armaments. Replication of the American M3 Halbkettenfahrzeug should be pursued in limited number, estimated requirement 5,000 units, subject to available industrial capacity. Albert Speer himself reviewed the proposal. The Wehrmacht's motorized divisions were collapsing under logistical strain too: few trucks, too few, repairable half-tracks, too much maintenance per kilometer of movement. The Americans had solved all of those problems with one machine, but replication was impossible. Germany simply did not have the industrial base for it. The M3's success depended not on secret materials or advanced design, but on something the Reich could no longer reproduce: industrial scale, cheap steel, and labour abundance. When Kleist returned to Kummersdorf in late autumn, he was told the project was being shelved. Wartime priority had shifted back to tank production. The prototype copy, assembled painstakingly from reverse-engineered drawings, remained unfinished. Its German components, built to higher tolerances and with heavier armour, weighed nearly a ton more than the original. Its steering proved stiff, its top speed lower. In the quest to replicate the M3, the Germans had unknowingly destroyed the very principle that made it work: balance through simplicity. Kleist wrote in his final report, dated November 5, 1943, "The American vehicle is the embodiment of a philosophy we have never embraced, that of sufficiency. Where we seek excellence through precision, they achieve endurance through excess. They make many, we make few, and the outcome is already visible across every front." He never saw another captured M3. By the time Allied forces crossed the Rhine, the Germans no longer had the fuel or steel to dream of replication. Yet, among the engineers at Kummersdorf, the half-track remained a subject of quiet reverence. It was, in their words, the machine that proved America's army rolled on wheels of steel and philosophy of plenty. The winter of 1943 settled cold and damp over Kummersdorf. The half-track stood beneath tarpaulin covers, its olive-drab paint contrasting sharply against the grey concrete of the testing bay. Oberingenieur Hans Kleist and his team resumed work in December, this time under the quiet supervision of Heereswaffenamt Abteilung Wahrprüf 6, the department responsible for motor vehicles and armoured technology. The directive was clear: determine precisely how the Americans had built so many of these machines and why their mechanical performance defied German expectations. Testing began with routine endurance trials. The captured M3, its Hercules engine freshly tuned, was driven across the frozen fields of Brandenburg. The observers expected a quick failure. American engines, they reasoned, were optimized for the mild climates of North Africa and the highways of France, not for the bitter cold of a Prussian winter. Yet the half-track started on the first attempt. Its carburetor, uncomplicated and robust, compensated automatically for temperature change. The battery voltage barely dropped despite the chill. In the driver's seat, a mechanic named Rolf Lenz muttered that his SD, KFZ, 251 at the front, had refused to start for 3 days in Russia the previous February. For 6 hours, the M3 circled the frozen proving ground. When they measured its engine temperature, it held steady at 80 degrees Celsius. The clutch and gearbox operated without grinding. Not a single bearing seized. The engineers took notes in silence. German vehicles of comparable class, particularly the 251 and 250 half-tracks, required constant lubrication and adjustment under such conditions. The M3 demanded nothing but fuel. Kleist disassembled the gearbox for closer study. Inside, he found gears of ordinary carbon steel, machined without the mirror-polished precision that German doctrine demanded. The teeth bore simple case hardening, adequate but unremarkable, yet the wear pattern after 6 hours of operation was minimal. American engineering, he realized, relied not on superior materials but on intelligent compromise. The gear ratios were chosen for flexibility rather than efficiency. The bearings were oversized to tolerate manufacturing variants, and the oiling system was designed to flood rather than target, reducing dependence on tight machining. He recorded his observations in a report later summarized by the Waffenamt. The design displays a philosophy of redundancy rather than precision. Where we economize in material, they economize in design effort. It was not meant as criticism. It was an admission of fact. The real shock came when they tested the suspension. The German STI, KFZ 251 employed a complex interleaved wheel arrangement, overlapping road wheels that distributed weight evenly, but required elaborate machining and constant cleaning. The American M3 used a vertical volute spring suspension, consisting of paired road wheels mounted on a simple bogie. Each bogie pivoted independently, absorbing shock through heavy coil springs. Maintenance required no specialized tools. Field photographs from Sicily showed American crews replacing entire bogie assemblies in under 1 hour. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The test team replicated this procedure. With only a jack, a wrench, and a hammer, 2 mechanics removed a damaged bogie and replaced it with a spare in 42 minutes. German field manuals estimated 3 hours for a comparable repair on the SD, KFZ 251. The implications were devastating. On the front lines, time and simplicity determined survival far more than theoretical performance. The test drivers found the half-track forgiving to steer. Its combination of front-wheel control and track braking produced a turning radius half that of German designs. This gave it extraordinary maneuverability in narrow streets and mountainous roads, a feature American infantry appreciated in the Italian campaign. When they tested it over obstacles, the M3 climbed a 40-degree slope without protest. The engine, though smaller than the Maybach HL42 in German vehicles, delivered steady torque at low revolutions. It was underpowered by German standards, yet unstoppable in practice. In early January 1944, the test team compiled comparative data. The M3 had logged 600 kilometers with no major failures. Average fuel consumption was 1 litre per kilometre higher than the SD, KFZ 251, but maintenance requirements were dramatically lower. Oil changes every 500 kilometres, spark plugs every 1,000, and almost no lubrication points. German vehicles required servicing every 200 kilometres and carried complex lubrication charts listing more than 50 fittings. The results went to Berlin, where Albert Speer's ministry analysed them alongside reports from field units. The conclusion was uniform. The American vehicle's operational availability, the percentage of time it was ready for combat, exceeded 90%. German half-tracks averaged barely 50%. A special conference convened at the Reichsministerium für Bewaffnung und Munition in February 1944. Among the attendees were Kleist, representatives from Büsing NAG, Auto Union, and Henschel, as well as officers from Panzergruppe West. The meeting minutes, later recovered by Allied intelligence, summarized the exchange. One colonel remarked bitterly, "We can make the Tiger tank, but we cannot make a truck that runs every day." Another added, "The Americans have won not by armour, but by axle." The engineers presented Kleist's findings. To replicate the M3, Germany would require new stamping presses, welding jigs, and assembly line procedures similar to those used in Detroit and Cleveland. Each M3 required roughly 800 man-hours of labour to produce. ASD, KFZ 251 required over 2,000. The half-track's entire body was welded from straight plates, with minimal curvature perfectly suited for rapid fabrication. In contrast, the German vehicle used complex angled armour, pressed and shaped by scarce skilled labour. The Americans had turned geometry itself into a production advantage. At one point during the conference, Kleist was asked whether the Americans' quality control could possibly sustain such scale. He replied quietly, "They do not check every part, they check the process." It was a phrase almost no one in the room understood. German industry still relied on master craftsmen, inspecting each component by hand. Statistical process control, the method pioneered by Walter Schuhart and embraced by American manufacturers, was virtually unknown in the Reich. To the Germans, the idea of trusting machinery to build machinery seemed reckless. To the Americans, it was the foundation of modern industry. By spring 1944, a handful of captured M3s had reached the Automotive Testing Center at Stettin. There, engineers attempted partial production using domestic materials. They failed almost immediately. Germany's shortage of quality rubber made the front tires unreliable. The track pads, a combination of rubber and steel, crumbled after short use. Lubricant shortages forced substitution with inferior greases, leading to bearing failures. The German copy, heavier by design and built with greater precision, paradoxically performed worse. Kleist's notes from this period reflect a growing disillusionment. He wrote, "We continue to believe that skill can substitute for abundance, but our skill is now chained by scarcity." He understood that the M3's secret was not mechanical at all, it was economic. It embodied the American system of mass production in its purest form, interchangeable labor, interchangeable parts, and a design stripped of every unnecessary refinement. Meanwhile, on the battlefields of France, the half-tracks were proving their worth beyond all expectation. Reports from the Normandy campaign indicated that American armored divisions fielded over 1,500 half-tracks each, ensuring near-complete mobility for their infantry. The SD KFZ 251 had been intended to serve a similar role, but production limitations meant most German infantry still moved on foot. The irony was unbearable. The nation that worshipped the motor vehicle had become an army of pedestrians, while the nation once mocked as a land of farmers now rode to victory in steel caravans. As Allied forces pushed into Germany in early 1945, Kleist's work at Kummersdorf became irrelevant. The last of the fuel stocks ran out. The test vehicles stood idle. When Soviet forces captured the facility in April, they found the M3 still parked under its canvas cover, remarkably clean, its logbook still on the dashboard. A Russian engineer, inspecting it, reportedly remarked, "So simple, even we can build this." And indeed, after the war, the Soviet Union and later Eastern Bloc nations would produce their own half-tracked vehicles inspired more by the M3 than by any German design. Kleist was captured and later interrogated by British intelligence. In debriefings, he spoke candidly about what the M3 had revealed. One officer recorded his statement, "We believed war was won by brilliance. The Americans proved it is won by consistency. Their machines work not because they are perfect, but because they do not have to be." It was, in a sense, the epitaph of German engineering under the Third Reich, an empire that could produce wonders, but not enough of them to matter. The M3 half-track would remain in service with Allied armies for decades after the war. France, Israel, and numerous smaller nations rebuilt their post-war armies with American surplus. Some would still be in use during the wars of the 1960s. Germany's own post-war Bundeswehr briefly evaluated surviving examples before transitioning entirely to wheeled armoured personnel carriers, a tacit acknowledgement that the lessons of the M3 had finally been learned. In retrospect, the M3 represented more than a vehicle. It was a philosophy rendered in steel, that reliability and abundance, not sophistication, determine endurance. The Germans had captured one machine but never grasped its essence. For every Tiger tank that stalled on the road, 100 half-tracks carried Allied infantry forward. In his final letter before internment, Hans Kleist wrote to his wife, "I have seen our future in an enemy's machine. It was built not by geniuses, but by thousands of steady hands. And that is how they won." The half-track was not beautiful, it was not elegant, but it worked endlessly, indifferently, across dust and snow. In the end, that quiet dependability defeated every dream of precision the Reich had ever cherished. The spring of 1945 ended with the noise of collapse. Berlin burned. Kummersdorf fell silent beneath the advancing Red Army. In the rubble of what had once been Europe's most advanced military-industrial complex, the remains of captured American and British equipment lay scattered among broken tools and empty filing cabinets. Somewhere beneath that debris stood the M3 half-track, the same vehicle that had confounded German engineers just 2 years earlier. When Soviet investigators catalogued the site in May, they recorded a curious list of recovered items. 1 disassembled Maybach HL-42 engine, 2 German-manufactured torsion bars, and 1 nearly intact American half-track chassis marked White Motor Company, Cleveland, Ohio. The accompanying notes from Hans Kleist's test logs described the vehicle as fully functional after 600 kilometers, minimal wear. The Soviets, pragmatic as ever, and had little interest in its philosophical implications. They shipped the half-track to Kubinka for further study, but among the German technicians who survived the war, the memory of that machine lingered. For men like Kleist, who would later work rebuilding civilian industries under Allied supervision, the M3 became a quiet symbol of everything their old world had failed to understand. In the months after Germany's surrender, British and American occupation authorities began interrogating surviving engineers. Their questions were not about ideology or politics, but about process. How had the Reich produced such technically brilliant yet logistically fragile machines? Why had it failed to adapt to the war of supply rather than invention? Again and again, engineers cited the same moment. The testing of captured Allied equipment, the radio sets, the Shermans, the half-tracks, these had forced them to confront truths that propaganda had long concealed. For Kleist, who spent the late 1940s rebuilding vehicle plants in Hanover, the lesson was personal. He later told an Allied interviewer, "We learned that precision is not power, it is vanity." He explained that Germany's obsession with mechanical perfection had trapped its engineers in a feedback loop of refinement without scalability. Each new design demanded tighter tolerances, rarer alloys, more specialized labor until even success became unsustainable. The M3 half-track embodied the opposite. It represented an economy where every flaw was anticipated and absorbed by abundance. Its materials were unremarkable, its design unromantic, yet it was precisely this ordinariness that made it extraordinary. A vehicle that could be built by dozens of factories, maintained by soldiers with minimal training, and survive environments for which it had never been designed. Such an achievement required not genius, but humility. Post-war industrial historians would later identify this as the defining divide between the Axis and Allied war economies. Germany pursued complexity as proof of superiority. America pursued standardization as proof of efficiency. In 1944, the United States produced more than 8,000 tanks, 20,000 aircraft, and nearly 100,000 motorized vehicles in a single month. The Reich, under constant bombardment, could not build even 1/10 of that. In that arithmetic lay the real tragedy. For all the brilliance of German engineering, it was ultimately a closed system, self-referential, inflexible, enslaved to its own ideals. The M3 half-track revealed that the future of war belonged not to the craftsman but to the assembly line. The post-war Bundeswehr quietly adopted this lesson. When West Germany rearmed in the 1950s, its new armoured personnel carriers, the Schützenpanzer Lang HS 30 and later the Marder, bore the unmistakable influence of the M3's design philosophy. They favoured modular components, welded hulls, and easily replaceable parts. American production principles had become German doctrine. Even the factories that once built SD, KFZ, vehicles were retooled to produce civilian trucks under license from Ford, Opel, and Mercedes-Benz. In archives and memoirs, one can trace the subtle transformation of mindset. Engineers who once measured success in micrometers now spoke of cost per kilometre and mean time between failures. Industrial art had become industrial arithmetic. The ghost of the half-track haunted every calculation. In 1961, long after the war, Kleist visited the United States as part of a West German delegation studying mass production methods in Detroit. There, at the Henry Ford Museum, he saw an M3 half-track preserved among other wartime relics. He stood before it for a long time, noting the same stamped steel panels and simple weld seams he had once measured with calipers in Kummersdorf. A young curator approached and explained proudly that this particular vehicle had been built in 1942 by White Motors, one of more than 40,000 units turned out that year alone. Kleist smiled faintly and replied, "We tried to copy it once." The curator looked puzzled, perhaps thinking he was joking. But Kleist was remembering the frozen proving grounds of Brandenburg, the endless reports, the futile attempt to replicate a philosophy with a file and hammer. "It was not the machine we failed to copy," he added quietly. "It was the system that made it possible. That system, the fusion of industrial democracy, technological pragmatism, and managerial science, became the defining feature of post-war Western power. In that sense, the M3 was not just a tool of victory, but a messenger from a future the Reich could never reach." Historians of technology often describe the M3 half-track as a transitional vehicle, a bridge between the truck and the armoured personnel carrier, yet its symbolic value exceeds its mechanical form. It encapsulates the industrial character of total war, the shift from individual excellence to collective capability, from ingenuity to infrastructure. German soldiers who fought against Allied columns remembered the half-tracks vividly. They called them the moving walls, not because they were armoured, but because they never stopped coming. Every destroyed vehicle was instantly replaced. Every road seemed to produce more of them, as if the Americans carried factories in their pockets. To the weary infantryman, that endless procession was as demoralizing as any bombardment. It represented a kind of invincibility born of logistics rather than valor. In the final accounting of war, it was not the Tiger tank or the V-2 rocket that defined victory, but the unremarkable machines that never broke down. The M3 half-track, the Jeep, the GMC truck, these were the true instruments of conquest, not through power, but through persistence. When the archives of the Heereswaffenamt were finally opened decades later, researchers found that Kleist's technical notes had been carefully preserved. His concluding paragraph, written in early 1945, reads almost like a confession. "We have tested their machines and found them inferior in every individual measure, superior in every collective one. The Americans have replaced our philosophy of perfection with one of sufficiency, and in that replacement lies the future of engineering and of war." The line could serve as an epitaph not only for the German war effort, but for an entire civilization's faith in craftsmanship as destiny. The half-track itself survived its capture and its post-war testing. Decommissioned in 1949, it was stored in a Soviet depot outside Moscow until the 1970s, when it was quietly sold to a museum in Poland. Today, it sits behind a velvet rope at the Polish Army Museum in Warsaw, its olive drab faded, its rubber tracks long hardened with age. Few visitors notice the small plate beneath the windshield, captured in Sicily, 1943. Yet to those who know the story, that plate marks not just the fate of a machine, but the turning point of an industrial age. Standing before it now, one might imagine Kleist's words, whispered through the decades, an engineer's belated reverence for the plain and the practical. The M3 half-track, once dismissed as crude, had revealed the deepest irony of the Second World War, that in the contest between genius and geometry, it was geometry that won, and so the war ended not with the perfection of German engineering, but with the triumph of mechanical humility, a victory welded from ordinary steel, measured not in precision, but in persistence.